We humans experience time in a very specific way. It flows forward. We remember the past, but not the future. This is called time's arrow. But what if I told you that at the quantum level, the rules of time get a little fuzzy? Imagine a world where you could unscramble an egg, or where spilled milk magically leaps back into the glass. In the quantum realm, the equations that dictate the behavior of particles don't distinguish between forward and backward time. This doesn't mean we can hop into a time machine just yet, folks. But it does make you think, doesn't it? Now, let's get down to the nitty-gritty. Physics often presents equations that work just as well backwards as they do forwards. Imagine watching a movie of a billiards break. You could play it in reverse, and the laws of physics would still hold true. This time reversibility in physics equations gets even more mind-boggling in the quantum world. Particles can exist in a superposition of states, meaning they're in multiple places or states at once, only collapsing into a definite state when observed. This fuzziness about time's direction has some pretty wild implications. It suggests that, at the quantum level, the past and future might not be as fixed as we think. Just because the equations allow for it doesn't mean we figured out how to build a DeLorean to take us back to the Jurassic period. However, the very fact that these possibilities exist at the quantum level throws a wrench into our neat, linear understanding of time. Let's talk about systems. No, not the kind that run your computer, but the way physicists categorize different parts of the universe. First, we have isolated systems. Think of a sealed box, completely cut off from the outside world. In a truly isolated system, time would essentially be meaningless. Now, contrast that with open systems. These are systems that interact with their surroundings, exchanging energy and information. Our universe, as we know it, is a prime example of an open system. And this constant change is what gives rise to our perception of time's arrow. Even seemingly isolated systems, when you zoom in close enough, reveal tiny fluctuations and changes at the quantum level. Section 4. Two-timer. New research suggests time might flow both ways. Recent research suggests that open quantum systems might actually have two opposing arrows of time. Imagine a river that flows in two directions simultaneously, each current carrying its own set of leaves and debris. Now, this doesn't mean you'll bump into your future self on the street anytime soon. We still only experience time moving in one direction. But the fact that the math allows for two opposing arrows of time within these systems is a tantalizing hint that our understanding of time is far from complete. If we adopt a global perspective, taking into account the entire system and its interactions, the issue of time asymmetry might disappear altogether. Think of it like this. Imagine watching a movie where two characters experience time moving in opposite directions. Section 5. The Quantum Conundrum. Wrapping up with the mysteries of quantum mechanics and time's elusive nature. The quantum world, with its fuzzy timelines and backwards-forwards possibilities, challenges our everyday understanding of time. The very nature of time, something we take for granted with every tick of the clock, becomes a slippery, elusive concept in the quantum realm. But that's the beauty of science, isn't it? The more we learn, the more we realize how much we don't know. The quest to unravel the mysteries of time in the quantum realm is far from over. It's a journey that will continue to push the boundaries of our understanding, revealing new wonders and deeper truths about the universe we call home. Until next time, keep looking up.